Okay, so we want to find a confidence interval for proportion. We've seen earlier the formula for the lower bound is this. The formula for the upper bound is this. Okay, so we need to make sure that our sample is good. It's random and independent. We need the sample size to be large enough to guarantee that we've got the bell shape that we're using. And we need our population to be large so that we don't have dependence when we're choosing our sampling. Okay, so here's an example then. Let's say 1,034 Canadians were asked how would they vote, and 382 of the 1,034 said that they would probably vote for the Liberal Party. So let's find the sample percentage or the sample proportion. Okay, so here that's 382 out of the 1,034. Okay, so here this is a proportion. When it's a decimal, it's called a proportion, or probability is also in a decimal. If you want a percentage, then you multiply this by 100. That would be 36.94%. But proportions are decimals, percentages, of course, are proportions multiplied by 100. What is the sampling error? Again, we don't know exactly what it is because we don't know what p is, but we can estimate it by using p hat times 1 minus p hat divided by root n. Sorry, divided by n, and then take the square root of everything. In this particular case, then, here we found what p hat was. So here's p hat, 1 minus p hat, and divided by n. Okay, so here we're saying the standard deviation of the sampling distribution, also called the standard error, looks like it's 0.015. So let's find a 95% confidence interval. Okay, so here, again, if we want 95% confidence, 1 minus alpha is 0.95, so that goes in the middle. And then here, we've got 5% to share, and we're going to share it equally, so it's 5% divided by 2. So this is 2.5%, 0.025. Okay, these are going to be the z values that correspond. This first z value is going to be 0.025. Okay, again, here it is, 0.025. It's in the negative 1.9 and 0.06 combination. And then this range, one way you can do it is just to know that it's the positive counterpart. The other way is this is 2.5% plus 95%. So together, all of this cumulative area would be 97.5. You could also look up here 97.5. Okay, so it's going to be right here, 97.5. That is in the 1.9 row and in the 0.06 column. Okay, so here my values, my z values are 1.96. Okay, so here then I can write this formula, these two formulas just easily in one by using this operator plus minus. One way I'm going to add it, the other way when I go through I'm going to subtract it. Remember here that the standardized value, the number of standardized values times by the standard error is called the margin of error. So in this case, we'll just sub in everything that we know. P hat, we've calculated that here. Here the standard error, which is all of this, we've calculated here, so I'll just simply sub it in. And the number of standardized jumps is 1.96. The standard or the empirical rule suggests to be 95% confident we need 2 standardized jumps, and we can do a little bit better job when we're using the Z table. This is almost 2. You can see that it's close to 2, but it's really more 1.96. Okay, so here we've got our point estimate and our margin of error. We can wrap up by saying we are 95% confident the proportion here of all Canadians, not just our sample, but of all Canadians, this is of the population, who would vote Liberal, is between 34%, as you can see, and about 40%, as you can see here. So we are 95% sure. We're very highly assured. We're assuring ourselves that the percentage of people that vote Liberal will be 34, in between 34 and 40. Okay, so is there a chance this is wrong? Absolutely. Okay, so in fact, we're not even stating that we're 100% sure. We're saying we're 95% sure. The proportion of people that vote for Liberals truly could be anything, really. But we are 95% sure that it's between this and that. Okay, let me just quickly show you then how you could possibly do that in minitab. Okay, so here in minitab you can go to Stat, Basic Stats, and this is one proportion that we're talking about here. Okay, so do you have data in a column? No. What other options? I've got summarized data, yes. Okay, so what is the number of successes? We saw that there were 382 out of the 1,034. Okay, make sure we go to options here. Option says, how confident would you like to be? In this particular case, we said we wanted to be 95% confident. That is, in fact, the default, so if it's 95, you can kind of leave it that way. Here, what's the alternative hypothesis? Here, we'll talk about this a little bit in the week coming up, but we've got three options: less than, not equal to, or greater than. We want the not equal to sign because for an interval, we need both the less than and the greater than. We need both the lower limit and the upper limit. Okay, so we want the not equal to. And here also make sure, especially if you're using minitab 17, that the method is actually based on a normal approximation. Okay, so the default is the exact, and we don't want that. We want the method to be the normal approximation. If we press OK, then here it tells us we are 95% confident that the proportion is in between on the lower side 0.34 and on the higher side 0.398 or 0.4. Okay, so that is exactly what we got here as well.